Today we're going to be talking about how to train models remotely on RunPod and monitor that model training with Tensorboard. So let's start out with why. What is RunPod? Why would you want to use it? Well, if you are attempting to train a model and it's something that is either going to take a very, very long time to train, and you don't want to have to tie up your PC for that long, maybe something's going to train for 30 hours or 40 hours. Or maybe you're trying to train something that needs a more powerful GPU. Maybe you need more GPU memory for what you're trying to do than what your laptop has. Or maybe you even just want to test drive a GPU, a specific graphics card, and see how the performance would be for your training. RunPod is a platform that lets you go out and basically rent GPUs from people. They have both the RunPod, what they call their secure cloud, which I believe is in their data center, and you can see those are fairly expensive. And then there's also going to be a community cloud that we'll get into, and that's going to be quite a bit cheaper, on the order of 20 to 30 cents per hour, which really isn't bad if you're trying to run something. Maybe you're going to spend $5 on training. Yes, as a personal project that can get fairly expensive, but if you compare it to going out and buying a desktop with a 3090 or a 4090 in it, maybe paying a few dollars a weekend for whatever your projects you're building isn't that bad. In this video, we're not going to be doing a full model training. I'm basically going to be putting together some mock-up Python that will fake out what training a model might look like and help us set this project up. We are going to be doing it from scratch in one take. I don't have the code pre-prepped, so this will be a first, so let's see how it goes. So right off the bat, I am going to do a conda create, and I'm going to name it RunPod demo with Python 3.11. And our goal for this project, again, is just to create some Python that is going to fake what training might look like and log some things out to Tensorboard. And if you haven't used Tensorboard before, Tensorboard is it's a graphing program, basically. It's going to let you log information from your runs, from your training runs, and then show that in a visual display. And that's really, really important, especially when you're talking about things remotely, because you need to be able to see how your training's going, even though it's on a remote machine. So, all right. So let's go ahead and fire up. In this case, I'll be using VS Code. You can use whatever you'd like. And then let's set our interpreter to RunPod demo. And I'm going to be doing a train.py, just like I normally would. Let's see what I need here. I think I need to import time, import Tensorboard, import, and that's going to tell me that it's could not be resolved. So let's go ahead and create a requirements.txt, and I'm just going to do Tensorboard. Okay. And sure, we'll go ahead and launch it internally. We won't be using the VS Code integrated Tensorboard for the main demo, but it'll be useful here. All right. So we've got our Tensorboard. So let's go epochs equals 1000 for epoch in range epochs. Okay, and let's start out with some print output. Run epoch completed, and I'll add a comment here. Fake training run. Print loss, and we will create loss in a moment. Print score and score. Okay, so let's start with loss equals 0. We'll do loss equals 1. Or maybe we'll go higher. I wanna make it clear what we're doing. And then we'll do score equals 0 to start with. So let's come down here and we just want to generate some reasonable fake training data. So let's go ahead and say that loss equals loss times 0.99. So that ought to simulate loss going down. And you know what? We'll just say score equals, I'll make score 1 to start with. So score equals score times 1.1. And we'll go a little bit lower, 1.01. That ought to equal score steadily increasing. And then just so it doesn't blur by, we're going to say time.sleep 1. Okay, let's run this script and just make sure no module named TensorBoard. Okay, because we put it in our requirements.txt, but then we didn't actually install our requirements.txt. So I'm just going to come down here in the terminal, and we're going to do a pip install -r requirements.txt. Okay. And run this again. All right, and we see score steadily going up and loss steadily going down. All right, you know what? I actually do want score to increase a tiny bit faster, so I'm just going to say score is 1.05. That looks good to me. Okay, and now score is steadily increasing as we go. So let's go ahead and introduce the TensorBoard portion of this. And I'm going to take just a moment to pull that line. All right, so we actually don't want to import TensorBoard. We want to import from torch.utils TensorBoard, import summary writer. Okay, and that is not wanting to resolve, so let me take a moment and make sure I got my, you know what? It's not resolving because we haven't imported torch. All right, let's do that and install our requirements again. And that's going to take just a moment to install. Okay, while we are waiting on that, let's go ahead and get our summary writer built out. So this is going to be writer equals summary writer, and then we're just going to feed in a name. So we're just going to say big training, then down here, every single time we go and print, we're going to go ahead and say writer.add scalar. And the way Tensorboard displays things, if you start with, word1/word2, it's going to make word1 sort of a category and then display the metrics from word2 inside of it. And this will make a whole lot more sense when we get there. So I'm just going to say loss, and for now I'm going to say, let's pretend this is actor critic. We'll do loss actor and writer.add scalar loss critic. And we're just going to log the same loss for both of them. I know, doesn't make sense, but it's a fake situation. And then we're going to put in epoch, and that is going to give it a number to allow it to plot. So we'll be doing loss, epoch, and writer.add scalar, let's see, score/score. Because we're just going to put that in its own category. So, and that will be score and epoch. All right. So we've now got our fake run Python script here. Let's go ahead and run that. And I'm going to launch Tensorboard. Use current working directory. Okay. Oh, and you know what? One piece I left out in my fake demo. You'll notice it's putting the events right up here. I actually don't like that. I don't like how that's organized and how it's going to dump into the environment. So just like with the other place, if we do runs/fake training, it's going to put it in a runs directory for us. So let's just fix that. All right, cool. And now we've got our runs directory. We've got our Tensorboard here, and I see run/fake training. And my favorite view is to use scalars over here. And you can now see we have some graphs showing our loss happily going down and our score steadily going up. And you can apply some smoothing if this was noisy data. In this case, it's not, because we're just generating linear data. All right, so let's say that this was a big, bulky process now that you don't want to run on your laptop. You just want to offload this to the cloud somewhere. You are going to go to runpod.io and you're going to sign up. Go ahead and log in, sign up. You will need to go to billing and set up a payment. You can do this, you can do a couple of dollars. You can do, I think I do it usually in $5 increments. You can see here I have a balance of $11. So not something that's been terribly expensive for me. But you do need to come in here and go to billing and set up a credit card. You do not have to set up automatic payments. You can treat this as something that, you load up, and then when it's done, it's done. So let's go ahead and come over here and assume that you've already got billing set up and you want to deploy a pod. Oh, one more thing you have to do. If you don't have an SSH key already, you need to come over here, and hopefully if you have one. If you have one already, this will override it. So if you don't have an SSH key, you're going to run ssh-keygen and just hit enter until it generates one. And then that is going to create a public key in .ssh idrsa.pub. If you haven't played with keys before, so your private public key pair, you can think of your private key as the key that allows you in a door, and you can think of your public key as the lock. So with your public key, you are putting a lock that you own on that remote door. so that you're able to access it. That's what you're doing. It's always okay to share your public key. That's fine. You never want to share your private key. So my public key right here, I'm going to take this and I'm going to go under, I believe it's settings. Let's see. And then I can go to SSH public keys and then upload a key. Now I've already done this. You want to do this before you go any further in the video. So at this point, pause the video, make sure you have billing set up, make sure your public key is uploaded. All right, I'm going to assume all that's happened. Now we're going to come over here and go to pods and hit deploy. And I'm going to choose GPU because that's kind of the whole point. And you'll notice again, all of these are fairly expensive. You can see, the hourly price. Some of these are $2, $3 an hour. We don't want to pay $3 an hour. We don't need that much power. But this is all part of their secure cloud. So if you come up here and go from secure cloud to community cloud, these, as I understand it, are people who have contributed, a personal machine or small bank of machines and are leasing out their GPUs for use. So you can actually come down here and look at either latest gen, or I like to do previous gen because, why pay more? And then you can choose the GPU that meets your requirements. And this is where it gets cool. If you really, if you need a couple of days of an RTX A6000 with 48 gigs of VRAM, just grab it, 44 cents an hour. Over the course of a 24-hour training run, that's going to be $10. Not bad. Especially not bad compared to, whatever an RTX A6000 would cost you. So it looks like, I just Googled it, it looks like as of this recording, that is about a $4,500 card. So renting one from RunPod, if we say $10.56 is the cost for a day, $4,500 divided by 10.56, you would basically need 426 training runs, 426 days of just solid training to make it worth buying one of that card versus just renting one from them. So if you've been on the fence about should I build a really heavy deep learning machine, or maybe build a light machine and outsource when I need more compute, this is actually a much more affordable way to do it. So in this case, I'm just I'm running a fake process, so I'm going to look at what's cheap. It looks like an RTX 3080 is cheap and an RTX A4000 is cheap. So I'm going to go ahead and do the 3080. And then you can also pay less for an instance that can be interrupted if someone else buys it. In most real situations, I'm going to use on demand because I actually don't want my instances interrupted. In this demo, I'm going to use Spot because, 9 cents an hour, and I'm not actually going to run something all that long term. So let's go ahead and deploy Spot. I'm unchecking Start Jupyter Notebook because we don't need it. I'm leaving SSH terminal access checked. Oh, there are no longer any instances. So that's the thing with Spot. I tried to get it. Apparently somebody else grabbed it, or the price went up, and we went over to on demand. So we're now going to deploy on demand. I will pay a whopping 17 cents to do this demo for you. All right, our pod is running. Let's go and see if we can get our connect options. So in this case, we want the root connection. That's kind of what you want to build here. And I just want to go and make sure that we can log into it. Oh, hang on. So you notice out of the box, it is specifying a key file here. .sh/id ed255 blah blah blah. Since we're using our default public key, we can just get rid of that and then say yes. We want to add our key to the host, and we are now in. All right. So a couple of quick setup steps, and you could automate more of this. I'm going to keep it basic and let you form this to your workflow. So I'm going to create a directory called /app, and then project1. And then we're going to come back over here to VS Code, and we're actually going to create a really simple script that will let us easily deploy the code to RunPod. So this is going to be a shell script. If you are running on Windows, I'm sorry, but you probably need to go write some PowerShell or do this by hand, or but this portion is going to be much easier on Linux. So deploy runpod.sh. All right. So we're going to do /bin/bash, and I'm going to take in a RunPod host as $1, a RunPod port as $2, a RunPod project name as $3. All right, and then we're going to get into some SCP commands. So we're going to say scp-p runpod port, and we're going to copy, and SCP is secure copy. There are other ways to do this. There are tools like Ansible that would do it for you, but this is available just out of the box. So I'm going to say star.py to root at runpod host /app /runpod project name. And then I'm just going to copy this a couple of times. And we're going to do, actually, I may not even need two of them. I was looking at another one of my projects that's a little bit more complex. But in this case, I just need requirements.txt. And if you're wondering why wouldn't I just do star, well, maybe I've got my own training runs in here. Maybe I've got data. Maybe I've got models loaded. You do want to be a little bit more selective about what you copy up there. So that's now been built. I'm going to cancel out of this. And we are just going to go and take the URL that we had earlier from RunPod. So, we just coded in, let me grab this and stick it somewhere. All right. So we have our URL here from RunPod. We have our deploy runpod.sh that accepts 3 parameters. And you could do this from the terminal in VS Code. You could do it over here. I'm just going to run it from here. So I'm going to first chmod plus x deploy runpod. And we're going to do deploy runpod.sh. I'm going to pass in that IP as the first parameter, 26.196.142, and then we'll do 12.826. That's the port here, and then we named our remote directory project1. So let's try it. And in this case, it copied our 2 files up, and that is great. All right. So let's go and look at, let's go ahead and shell back in. So we're going to make a couple of changes to this shell command we ran earlier. So in order to run something like Tensorboard remotely and get those variables or get that information back on our machine, we are going to have to do what's called SSH port forwarding. So we're going to have to forward the remote RunPod, or the remote port for the TensorBoard installation back to our machine. So I'm going to go ahead and do SSH -L, and I'm going to do 4444 locally, localhost, and I'm going to choose 6006 for TensorBoard. You could use different ports. It's just going to be what we're running it with. So that should forward 6006 on the remote system to, actually, let's just go ahead and do, because I might have TensorBoard running, I'm going to do 4445 locally. I mean, that does kind of start to tell you how arbitrary some of this is. So, all right, so we're forwarding 6006 to 4445. We're going to go to /runs, or not run, /app. And then we're going to go to project 1. All right, and we are going to pip install -r requirements.txt to load our requirements onto this system. All right, and then we're going to use something called nohup to help backlog this process and send the output to a nohup.out file. So nohup, N-O-H-U-P, Python, train.py, and then an ampersand. And then if we tail this file, we should start to get some output in a minute. It should start to print some things for us. In the meantime, we're going to do, and let's just psef grep Python, make sure it's actually running. Okay, cool, it is running. So let's also go ahead and we're going to launch TensorBoard. --logdir equals runs, and --port equals 606. All right. So we've now got TensorBoard running remotely, and we should be able to come to our local browser now. And I think I said 4445, and if everything's working, hey, we've got TensorBoard. And so what you're now seeing is you're seeing training running on a remote machine, a remote GPU-enabled machine, and you are seeing the statistics from that training presented in a log directory that we are now watching. And I can hit reload data, and it'll just check every 60 seconds for new data. So yeah, if this was a real training project, if this was a real, RL project, I could now just walk away and just let it run. Because we ran it with nohup and an ampersand at the end, that training process is just going to continue without us. If we lose the SSH connection, this will go away. So that is something to be aware of, is that you do have to maintain your SSH connection. If you wanted to be able to do other things in that terminal, you could easily just do the same thing with TensorBoard. So you'll notice I killed the command. This is now no longer, that's dead. So if you wanted to run this in the background, yes, I know. Nohup and ampersand. So we can throw TensorBoard in the background as well. And now that it's back up and running, we should have our metrics again. All right, and with that, that's the end of the video. You now know how to spin up a RunPod and go and get your logs from it. If you wanted to, let's say you successfully trained something and you outputted a model and wanted to copy things back up or back down, you would basically just reverse this copy command. So you would do SCP, you would do your root at RunPod host app, RunPod project name, and then whatever your output file was, and then you would put it in a local directory. So this gets it out there, flip that around, and that'll get it back to your machine. And then, of course, importantly, let's not forget to go and terminate this instance because it is charging you money every hour that you run it for as long as you run it. So I'm going to go ahead and go back to pods while we're here and stop pod, and then terminate. And now my pod is gone and I'm no longer being charged money. All right, until next time.